This is the story of Mr. Ohm and Mr. Bell. Ohm's law was named after George Ohm. He was born in 1789. Ohm's law defines the mathematical relationship between volts, amperes, watts, and ohms. There are two fundamental equations that include these four properties of electricity. P stands for power, measured in watts. I stands for intensity, or current, measured in amperes. V, or E, stands for electromotive force, or electrical potential, measured in volts. R stands for resistance, measured in ohms. Z stands for impedance, which is also measured in ohms. It is important to know that power is equal to the product of the current and potential as expressed in this equation, P equals I times V. Potential is equal to the product of current and resistance as expressed in this equation, V equals I times R. Ohms are equal to the ratio of potential, volts, over current, amperes. Ohms equals V divided by I. Impedance may be easily defined as the total opposition to the flow of AC, but remember that it determines the ratio of voltage to current. Higher impedance at an input leads to better transfer of the signal voltage. Lower impedance speaker loads connected to amplifiers allows for higher power output. Alexander Graham Bell was a pioneer in signal transmission and communication. His tireless dedication to science provided and inspired countless innovations and continued research. There are many reference scales that use decibels to indicate voltages, power levels, and acoustic sound pressure levels. Some of those scales include dBu, dBV, dBm, dBFS, dBSPL, and dBVU. The dB, or decibel, is purely a ratio that on its own indicates no specific value, only a ratio. When one of the aforementioned suffixes is added, it indicates that the ratio is referenced to an industry-standardized specific value at 0 dB. The reason for the decibel's logarithmic nature is to handle very large ratios with more reasonable powers of 10. For example, given the equation 10 to the third equals 1000, the different operators can be labeled as follows. 10 is the base, 3 is the log, and 1000 is the antilog. Note that when working with base 10, the antilog has zeros equal to the amount of the log. Most people recognize the 3 in that equation as the exponent, or power. Acoustic volume is measured according to the dBSPL scale. Professional audio signal is measured according to the dBu scale. Consumer audio signal is measured according to the dBV scale. Digital audio is measured according to the dBFS scale. The dBVU scale on electronics is set according to the standardized reference level of the device's application. The reference standard may also be referred to as nominal line level or unity gain. Unity gain is typically set to 0 dBVU. 0 dBu is referenced to 0.775 volts. 0 dBV is referenced to 1 volt. 0 dBm is referenced to 1 milliwatt. Professional unity gain is typically plus 4 dBu. Consumer unity gain is typically minus 10 dBV. So professional signal level voltage is typically around 1.23 volts, while consumer signal level voltage is usually around 0.316 volts. Professional signal level is approximately 4 times as much as consumer signal level. There are 4 shortcuts to remember. A 2-to-1 power ratio is equal to approximately 3 dB. A 2-to-1 voltage ratio is equal to approximately 6 dB. A 10-to-1 power ratio is equal to 10 dB. A 10-to-1 voltage ratio is equal to 20 dB. Math helps inform your decisions so your actions can be deliberate and effective. Numbers are our friends because without us, they have no meaning. So don't be afraid to add, subtract, multiply, divide, use exponents, roots, fractions, ratios, logarithms, and algorithms. You probably already do, but you may not realize it. Now here's a song that will hopefully help you remember.
Direct current, that's DC. DC comes from a battery. Alternating current, that's AC. It comes from the outlet where you plug your TV. These are the kinds of electricity. Current is a measure of the rate of flow. Voltage is electrical pressure, you know. Power does the work that can make things go. Resistance, like the brakes, can bring it to a slow. Current is I and power is P. Resistance is R and voltage is V. Ohms measures resistance and impedance with a Z. Impedance is the total opposition to AC. Voltage over current is how you get ohms. This is a song to get ohms in our domes. Ohm's law is the equation we need to define these things mathematically. Current is a measure of the rate of flow. Voltage is electrical pressure, you know. Power does the work that can make things go. Resistance, like the brakes, can bring it to a slow. Current is I, power is P, resistance is R, and voltage is V. P equals I times V. V equals I times R. Voltage over current is how you get ohms. This song can help get ohms in your domes. Current is I, power is P, resistance is R, and voltage is V. Now let's look at decibels. Talking soft. Then I yell. Meters show us on our gear dynamic range of what we hear. dB is for decibel. The suffix indicates its scale. A logarithmic ratio keeps the numbers manageable. Don't be scared, I bet you know logarithms from before. Ratios are simple too. They compare two values. Watts are the power, amperes are the current, volts are potential that push so we can hear it. The current is I, the power is P, resistance is R, and the voltage is V. You heard me? 10 squared equals 100. Here's the same equation, logarithmically said. 10 is the base, 2 is the log, 100 is the anti-log. So the log base 10 of 100 is equal to 2. So the log base 10 of 1000 is equal to 3. 1000 has 3 zeros. dBFS, dBVU, dBm, dBSPL, dBu, dBv. So here's the shortcuts you should know to calculate decibels on the go. A 2-to-1 ratio of power is approximately 3 dB. A 2-to-1 ratio of voltage is approximately 6 dB. A 10-to-1 ratio of power is exactly equal to 10 dB. A 10-to-1 ratio of voltage is exactly equal to 20 dB. Current is a measure of the rate of flow. Voltage is electrical pressure, you know. Power does the work that can make things go. Resistance, like the brakes, can bring it to a slow. The current is I, the power is P, resistance is R, and the voltage is V. You heard me? Thank you, Mr. Ohm. Thank you, Mr. Bell. Your brilliance is acknowledged. Your science cannot fail. Current is I, power is P, resistance is R, and voltage is V. You heard me.